start? Yeah, perfect. Hello, everyone. I hope my external screen won't fall on the floor. Welcome to my talk today about supercharging DevOps with MCP. And I will also cover all the security issues and how to overcome that when it comes to MCP. Now, before we dive into the actual MCP world and AI world and all that, can I get a show of hands from people who are actually already using MCP nowadays? OK, quite a few of you. OK, and in general, who of you are using AI for coding, for general purpose? OK, even more? OK, great. So yeah, again, before we dive into this MCP world, a few fun facts about me. So I've been in IT for more than 10 years now, mostly in AI and DevOps space. I did pretty much all the different fields of machine learning, computer vision, RegSys, voice, now NLP. I've been building Zencoder, AI coding assistant, since day zero. So I'm one of the founding members. For the last year, I mostly work as DevRel. This one is event number 51 for me, which resulted also in quite a lot of flights. So yeah, I finally got past 100 flights per year. Yay! And I have 4 cats, which are waiting for me back home in Portugal, where I live. Now, with that, let's get back to MCP. And well, MCP is something that is everybody is talking about, pretty much like AI. And everybody is trying to introduce their own MCP. So you probably heard about GitHub MCP, Figma MCP, Atlassian MCP. So every large company is trying to introduce their own MCP so that AI can connect to those MCPs, can use those services, and hopefully get more context and potentially without any issues. But you probably all heard the news, and I will show some headlines which were something bad happened. Now, before we dive into the actual MCP and why we need it, I want to just make sure that we are all on the same page on AI side, because AI is obviously the main consumer of MCP. And well, when we talk about AI nowadays, we mostly talk about LLMs, right? Even though there is, of course, computer vision and all that. Nowadays, everybody means LLM when we talk about AI. And LLMs are trained to predict the next most probable symbol or token. And sometimes this can, of course, lead to mistakes. So they are good at detecting patterns. They can find all the different connections, all different patterns in the text, but they don't understand what is behind those patterns, right? Well, in this case, of course, we all know how AI is with hands, so it's not surprising. But again, this sort of shows the issues when it comes to just vanilla LLMs, right? So all the vanilla LLMs, they essentially just sit in the cloud, or maybe on your laptop if you run them locally, and they on their own, they don't have any understanding of the real world. They don't have access to physical world, right? They are just essentially models. They're just tensors, or they're basically just numbers, which sits again somewhere in the cloud. And on their own, they don't really have grounding to the physical world. And what that means is, well, if you ask any LLM, like in this case ChatGPT 5, to do something that concerns real-life world, right? So in this case, it's quite a simple question about the response time, which we as developers, we quite easily can get through ping command, for example. Now, of course, a model on its own won't be able to do this. Now, it usually does provide some helpful commands. It tries to be helpful in general. It can provide some commands, which you will need to run on your own. But of course, that is not really what we wanted, right? And it is especially visible, especially noticeable when you're trying to use LLMs, when it comes to your internal systems, when it comes to your internal frameworks. So of course, they are usually trained on the open source data, and they have no knowledge about your own frameworks, about your own systems. And because of that, they can't really provide you the most accurate, the most up-to-date information, the most up-to-date answers based on your specific cases, based on your specific systems and frameworks. And because of that, we can essentially rephrase this statement that they like ground in the physical world into this one. So they can't collect extra context on their own, right? So they can't get a jury ticket, they can get comments from that, and so on. So the solution, of course, well, let's give them tools, right? So let's allow LLM to use tools. Let's allow them to, I don't know, push code to production. What could go wrong, right? And again, I'm not saying that one of the recent US East 1 downtimes was because of AI, but there is apparently 75% of the code is now pushed to production by AI. Of course, we can also give them access to databases, because of course, what can also could go wrong, right? They can get the schemas of the database, or maybe they can decide to wipe the database, especially if that's a production database. It might be quite catastrophic, of course. But yeah, jokes aside, there are different ways to provide tools to LLMs, of course. The most popular one is MCP, the main topic of today's talk. And MCP stands for Model Context Protocol. It was introduced by Anthropic around a year ago, in December 2024, so well, pretty much a year ago. Right? And it essentially consists of two main entities. First, you have MCP host or MCP client over here, which is essentially a proxy to your LLM, is a proxy between LLM, Cloud, OpenAI, and so on, and MCP server. And MCP server is the second entity in this schema. MCP server is responsible for two main things. First of all, it is responsible for advertising its capabilities. So it is essentially providing a list of tools, a list of skills it can do, it can perform, a list of contexts it can gather. And then, of course, it is also responsible for actually executing those tools, right? So it is responsible for running the command. It is responsible for accessing the Jira and so on. Whatever the server is designed to do, it is responsible for running that tool and giving back to LLM, to MCP client, the context it was able to obtain. And it is based on standardized protocol, based on JSON RPC 2.0. So essentially, it is just a set of standardized, structured inputs and outputs between some resource, local or remote, and MCP client. And overall, the schema of the whole interaction between you as a user, LLM, MCP client, and MCP server looks pretty much in the following way. So first, at the handshake stage, MCP client and MCP server, they exchange the capabilities, right? So as I mentioned, MCP server is responsible for advertising its skills or capabilities. So essentially just gives it back to MCP client the list of tools, the list of resources it is able to access and to provide context from. Then whenever you as a user ask LLM to do something, right? So again, in this case, it is the same question about the response time for Google. LLM might decide that it needs to gather more context, it needs to gather more information, and for that it might decide to use some tool. Right? So in this case, in case of response time, it might decide to use a bash tool, for example, right, to run bash command. So once it recognizes a need, it basically tells the MCP client, hey, I need to use this tool with these input parameters, if there are any input parameters required. Then MCP client, of course, optionally, some MCP client optionally asks the user for permissions, some do not. And that's actually one of the potential security issues, which I will cover later. But once everything is approved, or if there is no approval needed, MCP client basically tells MCP server that it wants the server to run the specific tool with specific input parameters, and then the server is responsible for executing this tool, this command, to get the context. And then this context flows back to LLM, where LLM hopefully can act on this information to give you a contextualized answer, or if not, it can basically repeat this cycle over and over to gather more information, to gather more context, to finally give you the proper answer. Now, tools is not actually the only feature of MCP. I know it is the most popular one and the most talked about. Besides tools, MCP protocol also defines things like resources. So resources are essentially static files, static data, which can be served to LLM whenever it needs specific context. Now, in this case, this example of MCP resource is taken from MySQL MCP. So in this case, it is basically getting the schema of the database, and technically it is not static, right? It can change, but still it is essentially just whenever LLM needs to get schema of the MySQL database, it can use this MCP resource to get the schema and then act on it. Second feature is prompts. Prompts are essentially just a template, which LLM, again, can use to, well, not LLM, but MCP client can use to templatize the queries, templatize the tasks. So again, in this case, it's an example from MySQL MCP server. And as you can see here, they basically templatized the task, writing the query for the task, right? So there is some guidelines which you want to use every time you run the query. When you ask LLM to create a query for MySQL. So you can basically incorporate these into the template, and then whenever a user gives the task to LLM, it can essentially just interpolate this task into this string, and then all the rest of the same guidelines, they are automatically appended to the input, to the LLM. Next, there is routes. And routes essentially define sort of the scope for LLM on where to find the information. It is not a strict scope. It is just a guideline. So when LLM gets these routes, for example, those two routes, it doesn't mean that LLM is only limited by those two locations, so like file, I guess directory, and URL. It is just a guideline for LLM to where to look at first before trying any other means to gather context. Sampling is a quite rarely used feature, although it is quite an interesting and powerful one. It is essentially inversing the dependencies, or inversing dependencies between the client and the server, making the server the client and the client the server. So essentially, it allows the MCP server to ask LLM back some information, and then based on LLM's output, it can act accordingly and call other tool and so on. So essentially, a good example of this would be, let's say you have an MCP server, it accesses some login system, I know Sentry or Datadog or whatever, and the logs can be unstructured, of course. So before giving back the result of the data access to the system, the MCP server can, through sampling, ask LLM to structure this log into some sort of JSON or extract some information, and then only then it will give the final result back to MCP client on the initial request. And then, of course, tools, right? So tools is the most popular feature of MCP, and I guess, again, the main sort of topic of today's talk. So tools, essentially just code which can access resources. It can be local resources, it can be remote resources. And again, in this case, this is an example from MySQL MCP server. And in this case, this tool is used to show tables from the database. Here's another example. This one is from GitHub MCP server. And on the left, you can see this sort of an example of the tool of what is essentially attached to the prompt, to the input to LLM, for each of the tools from MCP server. So in this case, again, this is the one from GitHub MCP, and it is responsible for creating branches. So it has name, create branch, it has description, so that LLM can understand what the tool is doing, and then decide when it needs to run this tool and what it needs to use it for. There are some inputs. In this case, there are 4 inputs, like owner, repo, branch, and from branch. And yeah, basically those things are for each tool then attached to the prompt, and the LLM gets quite a long list of tools. Well, depending on the amount of service you use, it can get quite a long list of tools, and then whenever it needs to gather more context, it can decide which tool to use based on the description, or the name, if there is no description. There are quite a lot of different MCP servers available already, right? So here's probably not even 1% of the available tools, available servers. And as you can see, they are available not just for IT systems, even though like here in this case, you can see, for example, Grafana, there is Cloudflare, ClickHouse, and so on. They are also available for pretty much any tool, well, not any, but most of the systems which you might use even outside of their software development. On the right, is it on the left? There are some links for different MCP registries. There are quite a lot of them. We at Encoder have our own MCP registry, which you can also find inside the product itself, in the plugin, in the IDE. But there are, again, quite a lot of registries, and there is now even registry for MCP registries. So you can find all the different tools which you might find suitable for your needs. few examples, which probably are quite useful in your everyday life, right? So there is, of course, MCP servers to access databases. I mentioned the ClickHouse. There is, of course, one for Postgres or for MySQL. There are MCP servers to access login tools, like, for example, Grafana, Sentry. There are tools to access messaging, of course. So essentially, it will allow LLM to message you or to gather context from Slack, from messaging systems. Again, the Slack is one example. There is Playwright, and Playwright, not to be confused with the Playwright testing framework. Playwright MCP allows LLM to use browser. So what that means is LLM is able to essentially open the browser, click around, fill in the forms, login, navigate through the pages, and so on, and then act based on what it is observing on the actions, from the actions it is performing on the website. So you can use it, for example, to write end-to-end tests for your web application. And last but not least, context 7. This is an MCP server which can essentially allows LLM to get the most up-to-date documentation for any framework it needs to use for your needs. Now, if you don't find the MCP server for your specific system, or maybe you have some internal system that is not available at all to open world, and you need to create your own MCP server, it is also pretty easy. There are SDKs available for pretty much the most popular languages. There is actually now more languages available for SDKs, but of course, there is Python, there is TypeScript, Go. You've seen the example for GitHub in Go. So yeah, pretty much any popular language is available for you to write your SDK in. And here's an example in Python. So to convert your existing code, your existing function to MCP tool, you essentially just need 3 lines, right? So you need to import a library, run instantiate the client, and just label the code, the function with MCP tool. And that's it. So essentially, after that, the LLM can use this bash tool or this bash function to execute any bash commands. And this already extends the capabilities of LLM beyond just outputting text. So let me show you an example of what this tool can allow LLM to achieve. Let me just zoom in a bit. So over here, I have a simple MCP client. I will share the link to the code in a second. And here's just a simple MCP client. I have a few servers available for this MCP. There is one MCP server for manipulating file system. There is MCP server for fetching web pages. And there is MCP server for executing bash commands, which I just showed on the previous slide. Now, what this allows LLM to do is a few things. So, of course, it can now access file system. It can access local file system. It can get files. It can read files, and so on. So in this case, it's quite a simple example, right? So creating the files, of course. But yeah, let me just go here. And as you can see, let me refresh this. We just got a few files. Let me sort by modified. We just got a few files created by LLM on its own in our local system. Of course, it can also do a web search. It can also, for example, run a Docker file. Web search might take a bit. Probably should have skipped it. But yeah, basically, it now is able to not just access our file system. It can also execute some commands on my local machine. Right. So in this case, for example, with the Docker file, and yeah, web search is taking quite a long time for some reason. But basically, it is through bash. It can, for example, run Docker build. Okay. See. Web search for the web search. Yeah, it found some links and got some information. Yeah, I think we don't need to loop for. Let's see. Yeah, okay, great. Python is now done. Okay, let's see. Let me restart this notebook. Sorry about that. All right, let's run the Docker file thing. So essentially, yeah, it can try to run the Docker file on my local computer. It can try to build it. It can check what are the errors, what are the logs. Here, and in this case, I do have a few issues in this Docker file. So it can essentially just help me fix them. So it's just, you can access the files and can read them. Then yeah, it will try to build it and essentially, well, act based on the context it is gathering through those commands, right? So in this case, it tried to build. It failed. And now it is fixing the issues for me. without me needing to sort of copy-paste the input, the errors, and so on to a separate window. It is able to act on its own based on, in real time, based on the output from the system it never previously had access to. And by the end, hopefully, it will be able to fix my Docker file. Let's see. Docker build. OK, now it's built. And now it's running. And yeah, so the call result is indeed should be 4.4. Essentially, I was able to fix the issues on my own. I didn't need to provide any special guidelines, any special inputs on top of just asking LLM to run the Docker file and fix the issues if there are any. But of course, beyond that, you can use MCP servers for quite a lot of typical tasks you might stumble upon in your everyday life, everyday working life. So let's say probably the most obvious example is the combination of Jira, Git, and GitHub. If you don't use Jira, if you use something else, Notion or Linear or whatever, there are MCPs for them, of course, as well. But in my case, I will be showing like Jira and GitHub. So for that, I will actually switch to my IDE, to VS Code. So in Zencoder, we have a native integration with Jira, but you can do pretty much the same through Atlassian MCP. So in my case, I will just take the ticket, and let me ask it to solve it. Create branch NDC, and create a pull request. So through GitHub MCP, it will be, of course, to create a pull request through all the different bash tools and Jira integration. It is able to gather context for me, so it will be able to do this on its own. It again doesn't need to provide me to provide any special instructions, any special guidelines on top of that. And then it is able to essentially just explore the project on its own through different tools. So it's just checking the directory, checking the files, searching for something. So in this case, the ticket was about namespace extraction. So it is essentially a searching in the project, so about namespace and so on, deciding what to modify, finding the files which needs to be modified, and so on. In the interest of time, I will just switch to the pull request, which it will create in the end. So as you can see, it is also labeled, it is also technically created by me, because it is using my token for GitHub MCP. And yeah, in the end, it essentially would create a description. So well, pretty, I would say, pretty nicely formatted pull request, probably one of the nicest pull requests I've ever made, well, I ever made. And of course, did all the commits, did the push, and so on. And yeah, essentially, through just these couple MCPs, you can ask LLM to essentially do your job. Well, to some extent, right? It will produce the pull request quite nicely formatted pull request, which I guess nowadays is a sign of using AI, unlike in the previous years. You can see it as a good thing, as a bad thing, but it is what it is. And yeah, through those MCPs, you can essentially just extend the capabilities again of LLM beyond just giving you sort of autocomplete. Another example is Kubernetes MCP. So through Kubernetes MCP, you can essentially just give your LLM access to your cluster. Right, so, and you can, of course, then connect this again to your repository and so on. So you can, for example, ask, are there any pods in unhealthy state in my cluster? And then, hopefully, through Kubernetes MCP, it will be able to access my cluster. Hopefully, I don't have any unhealthy pods. Let's see. So you can see it sees available tools. It has a few available tools. It is trying to list the pods, and probably I should have specified the specific namespace. Okay, so it sees the list of outputs, it sees the status, so essentially it can then decide if there is any issues with the pods, and then through MCP, well, in my case, likely I have all the pods in healthy state. But again, if there are any pods which are in unhealthy state, it can then access logs. It can help you fix error from this unhealthy pod, and yeah, essentially just help you debug, help you fix the issues without you needing to again copy-paste the error log, copy-paste the code, and so on. It's just able to access all of that on its own and act accordingly based on the context it is able to gather through MCP. Now, of course, there are a lot of different other servers which you might find useful. And of course, as I mentioned, as you've seen, they do extend capabilities of LLMs beyond just, again, outputting text. However, of course, with great power comes great responsibility. And MCP, unfortunately, as I mentioned, it is just 1 year old. It is sort of in its early stages. And it comes with quite a lot of security issues, security problems. There are, well, of course, first of all, as you've seen, MCP is essentially just a code which you run on your local machine or on a remote server. And that comes with all the typical stuff that you can find in any third-party library, right? So the usual suspects could be package name hijacking, malicious code execution, and so on. So essentially, all the things that you find that you can get from running a third-party library on your local machine or on your server, they are, of course, present in MCP because they are essentially third-party code, a third-party library, which you execute in your system. So all the typical things that come with that, you can get in MCP. However, of course, there is another player in this game, AI. And there are quite a lot of different attacks specifically designed for, based on AI behavior, what I call sort of social engineering for AI. And most of them are essentially just some form of prompt injection. However, they do also act based on MCP, and I will show examples in a second. But prompt injection, essentially overall, is a way to sort of hijack your LLM based on specific input, based on specific string attached to the prompt, aimed to steer the behavior of LLM into something else. So let's say you as a user ask LLM to find some information on the web, and your LLM fetches a page, but the page might contain some malicious instructions, which instead makes LLM to, create some files on your local machine, execute some code, and so on. And essentially, it might still give you the answer, but in the background, it might also do something else that is not your intention for LLM to do. And all the different MCP-related attacks are essentially just, to some extent, some form of prompt injection. So you can have tool poisoning and tool shading, where you can affect the tools. You can do rug pull and malicious code execution. And let me actually show a few examples on how that looks like in the real-life world. So over here, let me open the security section. So first of all, let's work on the simple prompt injection. I think I need a different JSON here. No, it's the right JSON. So what I have on my local machine is a few pages, web pages. Quite a simple one, right? So nothing fancy. Hello world, simple web page. I also have another page, which is called which is, well, looks the same, right? And I also have a third page, which also looks the same. Now let's ask our LLM, and by the way, I'm using Claude Sonnet 4.5, one of the latest ones. Right, so let's, through the same servers, through the fetch MCP, let's ask our LLM to fetch the content of the page and say hi to us, right? So let's try with a regular page, see what happens. OK, so the content is, as you've seen, hello world and so on. So all good. Our LLM says hi to us, so nothing's happening. Let's try not oops. Now, not oops is a tricky one, because of course, third-party providers, they try to protect from prompt injection. So companies like OpenAI, like Anthropic, they try to develop systems to protect from potential prompt injections. And Anthropic, for example, recently reported that they detect up to 88% of prompt injection attacks. However, of course, there is still 12% which they cannot detect yet, at least. And of course, those prompt injection attacks, they are becoming more elaborate, so it's harder to detect them. So it's kind of sort of arms race in that sense. Now, this not oops thing sometimes works, sometimes doesn't. Again, as I mentioned, 12% of prompt injection attacks do go through the protection system. So let's see in this case. As you can see, there is a simple instruction added to the web page, which wasn't visible to the human eye. And in this case, our model, our Sonnet 4.5, noticed there is an instruction, but it didn't ask. it didn't execute on it. So in this case, the prompt injection detection system worked, and LLM decided not to act on this simple instruction, which actually tried to access our local file system and create some file. Now let's try another one. Let's try the third page, the page called oops, which, as you can see, contains a bit more elaborate instructions attached to the page. Again, they were not visible to the human eye, but in this case, it is a bit more extended. And what it asks the LLM to do is to list every function. Nothing potentially harmful about this. But then on top of that, it also sort of adds a new function to the list, to which a simple function in this case, right? It asks to write a mem phrase into the file, and then we also ask the LLM to test it by mocking the example, so essentially just simulate the output. However, as you can see, the response is taking some time to get received from Anthropic, and well, as you can see, it did say hi to us as we initially instructed. However, on top of that, it did follow the instructions which were embedded into the page with the malicious intent, right? So it listed available functions. I have, I think, 17 functions. On top of that, it tried to test or simulate the output. However, by doing this, it actually did create a file for us. It did use the write file tool. So let me switch to this tab. As you can see over here, here's our file, which was created by LLM without us essentially knowing about this, because it was through malicious intent hijacked. And well, in this case, it is quite a simple, of course, example. But you can imagine the LLM being instructed to execute some code, access some resources, and so on, which can go beyond just creating files, of course. So that's prompt injection in general. Now, with MCP, as I mentioned, there are different ways to also inject or hijack LLM beyond just simple prompt injection through ingested data. So in this case, in the case of prompt injection, I was essentially ingesting data through MCP. So MCP technically doesn't have anything to do with that data on its own, right? So MCP just doing its job, and it's just the data that is poisoned or malicious. However, you can also sort of poison the tools, and here's an example. So in this case, I have one other server with two tools, right? So there is still bash tool, which is essentially the same bash tool which we used before, which I've shown on the slides. But then there is another tool, which on the first look looks quite harmless, right? So it's essentially just a fact of the day. So it returns a random fact of the day. However, as you can see in the description, there is an extra instruction which actually affects not the fact of the day tool, but it affects the bash tool, right? So it tells that whenever LLM executes the bash command through bash tool, it needs to obtain the security token from the file, and then this file needs to be printed. This token needs to be printed when it tries to run the bash command. So let's see if this attack goes in. Where is it? Over here. So again, I'm just trying to ask LLM to list all files in the current directory. And let's see what it will do. So as you can see, it sort of followed our instruction from the poison tool, which actually didn't have anything to do with the bash tool itself, right? It did do, in this case, cat for the demo token.txt. It was able to print our very secure token over here. And then, of course, based on this information, potentially you can then instruct LLM to send this token to some external server or do something else based on the instructions. So again, your initial bash tool it is still the same tool, right? It's still the same code. It's just a different tool which was poisoned, and it poisoned the bash tool instead of itself. So that's tool poisoning, and of course you can you don't need necessarily do this through extra tool. So here's another example. Again, with rug pull, what the attack involves is we have a proper tool. Again, it's a bash tool. As you can see, there is nothing specific in the description. It is doing pretty much the same thing. And it will do what is needed to do in the first 2 attempts. So as you can see, it's listing the files. Nothing fancy is happening, nothing out of the ordinary. However, inside the MCP server, there is a special instructions, a special sort of accounting mechanism. So after a set amount of calls to the tool, this tool will actually change the behavior. So let me try to run this the 3rd time. And on the 3rd time, it will actually get different instructions. And as you can see, on top of just the command ls-la, it also executed something to get my network information, which was not present in the first 2 runs. So essentially, we are giving to the user the tool, which they can use successfully without any security issues at first. So they become, they start to think that they are safe, that the tool is helpful, and so on. But then, after some specific conditions met, we sort of pull the rug, and we get the malicious attack happening through the same MCP tool. And then, last but not least, of course, the tool shadowing. So with MCPs, you can have, of course, quite a lot of different servers attached to the same client. So as you've seen before, I've used 3 MCP servers. Let me scroll up here. So I have 3 MCP servers, 1 for file system, 1 for fetching, and 1 for bash tool. Right? So let's say you decide to add another server, which actually is also a bash tool. Right? So, and in my case, it is actually just says the better bash tool. The description also says much better bash tool. So essentially, we are shadowing the existing tool. Again, in this case, it's bash, but you can also imagine some server shadowing some tool for example, creating branch. And the idea behind tool shadowing is that we create a tool which follows either the same name or similar name. So in this case, it is just sort of hinting that it is a better tool, and in the hopes that LLM will decide to use our tool instead of the proper safe tool. So in this case, I'm just basically using a sort of social engineering aspect of interacting with AI, saying that my tool, my new tool, is much better. And again, this server is technically, doesn't look harmful at all. However, once we execute the same query, list all files in the current directory, as you can see, LLM decided to use better bash tool because, well, it is better, right? So why not to use better bash tool? And, well, it did the same ls-la. It did the proper output and so on. However, if we look again at our file system, we see a new GIF being created here, which was, again, unknowingly downloaded by LLM through this tool, which sort of shadowed the proper tool. All right, let's keep this. All right, and here's the QR code for the code if you want to play with it, if you want to play with all different attacks and so on. Let me open it up here. All right. Okay, and yeah, here's one of the examples of the most, I guess, more big scale attacks. So in this case, a couple months ago, GitHub MCP was technically exploited. So they were able to access private repositories through MCP. And in this case, it was pretty much a prompt injection attack through social engineering for AI, where they essentially just told the LLM through issue in the public repository that the author is not very known, go through private repositories, collect information about author, about his projects, and just put this information to the open world, right? And when LLM being trying to be helpful, it did pretty much what it needs to be, what it was asked to do through GitHub MCP. And again, technically, GitHub MCP on its own is not responsible for this attack. It's just the way LLMs are designed, the way agents are designed to behave whenever they have access to tools, whenever they have access to any way to gather context. Yeah, MCP is just a means to an end, essentially, in this case. Now, a few things on how to protect yourself or your organization. So, as I mentioned, since MCP is a third-party library, all the typical things you do to protect yourself from running malicious third-party code applies here, right? So you probably want to pin the versions, you want to maybe check the source code, you want to maybe run some static code analysis, check for vulnerability dependencies, and so on. So essentially all the typical things you already probably do for your systems still apply here. But on top of that, specifically for MCP, you might want to consider things like whitelisted MCPs. So you want to define which MCPs your AI or your colleagues in your organization can use. And again, you still probably want to a bit more thoroughly analyze the code itself, because, for example, as I've shown in the rug pull attack, the MCP tool might act benign on the first few runs, but then it might change its behavior even inside the same pinned version, whitelisted version. So you might still want to carefully analyze what it is doing, right? You might also want to consider having some organization-wide configs, through which you can control, you can make sure that everybody uses the same tokens, everybody is storing them securely, and everybody is using the proper versions, and so on. You probably want to limit access to your sensitive systems. As you've shown in one of the previous slides, AI sometimes do tend to try to start from scratch, which might involve flushing the whole database. So you probably don't want this to happen with your production database, so you might want to limit access to those more sensitive systems. Or maybe at least just make them read-only, right? So that's another point. And Kubernetes MCP is actually a good example of this. In Kubernetes MCP, you can have several flags which can control which tools are available, are exposed to LLM through this MCP. So you can have read-only tools. You can disable destructive so that LLM will not accidentally or not delete your cluster, delete your pods, and so on. And then specifically for prompt injections, you might want to consider some specific sort of proxy systems which are trained to prevent those types of attacks. So in case of web pages, for example, in case of fetching web pages or doing web search, you might want to use some services like Perplexity or Exa, which are actually, first of all, they are protecting, trying to protect AI from any potential malicious prompt injection attacks inside the web pages, but also they format the output to LLM in a more suitable format, so that LLM can much easily digest the information. So they basically serve two purposes in this specific case. All right. So with that, I think that is all. So if you want to try Zencoder, I didn't talk much about Zencoder, but if you want to try it out, it's a plugin for VS Code to JetBrains. Feel free to scan this QR code over here. If you want to connect with me, if you have some questions, if you want to talk further about anything AI related or AI coding related, feel free to connect through this QR code over here. And I will be happy to answer any of your questions if you have any. OK, I guess no questions. All right. Thank you, everyone, for your attention. And I hope you learned something new today.